Hello dear friends, good morning. Let's solve winter 23 component 2 on MCQ paper. Okay. Yeah, Hariharan Ponmani. 1. Which is a vector quantity? Okay, density is a scalar, mass is a scalar, pressure is force by area is a scalar, weight is a vector, weight is force. So D is right answer. Okay, next question. The graph shows the speed of a car traveling through a town. Okay, which section of the graph represents a period when the car is decelerating? Okay, so in a speed time graph, deceleration means negative slope. So which has negative slope? Which section has negative slope? A has positive, B has positive, changing but still positive. C is horizontal, so slope is 0, meaning it's going in a constant speed. So D is negative slope. So D is decelerating. Good. An object reaches terminal velocity after being dropped and falling through air. Which graph shows how its speed varies with time? Okay, so they are asking the terminal velocity graph in a speed time graph. Okay, let's see 4 options. Let's eliminate D first. Why? Because in a free fall, so initially whatever the particle is dropped, its velocity is 0. As it goes on, even if there is no air, the speed will increase. But in the D, initially it's high speed and then it's going down. So D is eliminated. We have similar graphs A, B, C except the gradient in the beginning part. Okay, so let us try to understand how terminal velocity works. Initially a particle or a ball, whatever it is, it's dropped, object, okay, it's dropped from free fall, it will be accelerated, okay, constant acceleration due to gravity, so its velocity will increase up to a certain point. Eventually the increase in velocity, the rate of change of velocity will decrease because of the air resistance, because air resistance is proportional to velocity square. Okay, as air resistance increase, you will have the velocity, rate of change of velocity decreasing, meaning that the acceleration decreasing until there is no resultant force to be accelerated. So you will be reaching down with a constant velocity. So you should have a 0 velocity in the beginning, 0 0 0 velocity, and then you should increase your velocity up to some point with decrease in acceleration. So you should have a gradient which is as it goes, it going flatter and flatter. Okay, the gradient should decrease. So in the B graph it's opposite, the gradient is increasing, and if you note at one point there is a sudden change in acceleration, so it will not happen. Acceleration change will happen over the time. So both A and B have sharp turns, so we can eliminate. So C is the right answer, and it's worth remembering this graph, how terminal velocity work. It will be handy at a time in exams. Okay, so initially it's 0 0 and then over the time the acceleration slowly changes until eventually no resultant force. When there is no resultant force, velocity graph is horizontal, meaning it's traveling with a constant velocity. Good. Okay, 4th question. The table shows the mass and volume of 3 different liquids X, Y and Z. Okay, they have mass and volume data. The liquids placed in same container, the liquids do not mix. Which liquid is at the top of the container and which liquid is at the bottom? Okay, so what we have to do, what quantity or parameter will determine which object will float, which object will sink, is density. So we have to calculate density of these 3 liquid. Whichever denser will be at the bottom, whichever is less denser will be at the top. Okay, let's calculate the density. We know that density is mass by volume. Okay, there is a mistake in unit. Density should be gram centimeter cube. Okay, so I'll correct this later. Yeah, so 120 mass by volume. Mass is 100. Let's calculate for X. Mass is 120, volume is 200. So 120 by 200 is 0.6 gram per centimeter cube. Next one is 80 by 67, which is 1.19 gram per centimeter cube. And then 100 by 120, so it will be 0.8 gram per centimeter cube. So out of this, I think the second one, y is more dense one, so y will be at bottom. So we have option A and option C, and then which is least dense? X is least dense, so X will be top, Y will be at bottom. Okay, yeah, so option A is the right answer. Which moving object has a resultant force acting on it? Okay, we have 4 cases. A driver rising vertically through water at a constant speed. Okay, he is rising vertically but at a constant speed, meaning that the upthrust is acting, but it was balanced by the viscous force of the liquid. So he is moving at constant speed, so no resultant force. So B will come back later. Yes, you guessed, that's the right answer. A train going up straight inclined line at a constant speed. So again, it's constant speed. Okay, of course going up straight incline requires force, but it was equally balanced, might be by the air resistance or by friction. So it's going constant speed, so there is no resultant force. A parachutist descending vertically at a terminal velocity. We know that in case of terminal velocity there is no there is no resultant force acting on it. So let's look at B. An aircraft circling an airport at constant speed. Okay, first it's constant speed, so we might think there is no resultant force acting on it, but it's circling an airport. So in circular motion, the resultant force is always towards the center. Okay, so B has a resultant force acting on it, and this is towards the center. So option B is the right answer. Okay, forces are applied to identical objects. The length of each arrow indicates the magnitude of the force. Which object is in equilibrium? Okay, they are asking which object is in equilibrium. What's the condition for equilibrium? There should be no resultant force, there should be no resultant torque. That's the condition for equilibrium. Let's look through one by one. Okay, let's look at object A. So the up force and down force have equal magnitude and opposite direction, so they will cancel out. But if you look at the left and right arrow, they are not exactly equal and opposite. Well, they are torque. Okay, they are acting in the tangential, so the object will rotate anti-clockwise. Okay, so there is net torque acting on it. Yeah, okay, let's look at C. Same as A, even though up and down forces acting on A, they cancel out each other, it will exactly look like C. So C also will have anti-clockwise torque, net torque. Okay, let's look at D. The magnitude of up is higher than the magnitude of down force, so the resultant force will be in the up direction. They are not exactly cancelling each other. So B is the right answer. Left and right both equal and opposite, so they will cancel each other. Up and down both equal and opposite, so they will cancel each other. So B, object B is in equilibrium. Nice. A sphere X collides head on with a second identical sphere Y, which is stationary. The mass of each sphere is 0.15 kg. Sphere X is traveling at velocity 2 meter per second before the collision and produces an impulse of 0.21 Newton second on sphere. What is the velocity of sphere X after collision? Okay, now what they are asking is, so there is a two spheres are there, X and Y. Y is stationary, X is moving with velocity 2 meter per second, and it's exerting an impulse of 0.21 Newton second. Okay, and then so the Y moves and then the X moves. What they are asking is with what velocity X moves and which direction. This is what they are asking. Okay, so we have to break down this question. First, let's find the final velocity of Y. Okay, why I am telling this is, if we find the final velocity of the y, then we know the conservation of momentum equation, m1 u1 plus m2 u2 equal to m1 v1 sorry m1 v2 v1 plus m2 v2. So this equation we know. So this required u1 u2 and v1 v2, so that we can find v1 final velocity of x. Okay, so how do we find that? We can use the impulse equation. So impulse is force into time equal to mass into initial final velocity minus initial velocity. So y m2 is m2 multiplied by v2 minus u2 is, we are finding the final velocity of object y, so that is represented by v2. So let's rearrange this equation for v2, ft by m2 plus u2. Okay, we know that force into time is impulse, that is 0.21, and then mass is 0.15 plus initial velocity of y is 0. So this gives us 1.4 meter per second. Okay, so now we find the final velocity of second object. Now let's take the conservation of momentum equation. Total momentum before collision is equal to total momentum after collision. Okay, but we can cancel out all the m since they are equal. Both m1 and m2 equal, so you can factor out the m and then cancel both sides. So we will get equation like this: u1 plus u2 is initial velocity of x and y, v1 plus v2 v1 plus v2 is final velocity of x and y. So initial velocity of x is 2, initial velocity of y is 0, so 2 plus 0. Initial velocity of v1, that's what we want to find. Final velocity of y, that is v2, we found 1.4. So if you put the equation, v1 is 2 minus 1.4, it's 0.6. We found the magnitude and its sign, it's plus 0.6 meter per second, which tells us it's in the same direction as x and y initially traveling, okay, or y traveling afterwards. So it's 0.60 meter per second in the same direction as y. So option B. Okay, next question. A cyclist travels down a hill from rest at a point x without pedaling. Okay, so he is in the top hill, so we just have to lean forward. The cyclist applies his brake and the cycle stops at point y. Which energy transfers have taken place between x and y? Okay, so initially he is in the uphill or top, so he has potential energy, gravitational potential energy, and then this potential energy is converted into kinetic energy as he is sliding down. And when he applies the brake, so the thermal energy, okay, the internal energy is happening, the friction between the braking pads and the wheel. So gravitational potential to kinetic to thermal. We have option like that. Yes, A. That's right answer. An object of mass m falls from a higher shelf to a lower shelf. How much gravitational potential energy does the object lose? Okay, so here is one small twist. How does the object lose? So let's find the potential difference between these 2 points, potential energy, gravitational potential energy difference between 2 points. So which is mg h2 minus h1 it should be. But since the question is how much it's loss, okay, so this is gain in potential energy, difference in 2 points. How much it's loss should be opposite sign. So if you introduce the minus, then if you look carefully, initially it was h2 minus h1, now it's h1 minus h2. So how much loss is mg h1 minus h2? Okay, next question. A pump does 460 kilojoule of work to raise water to fill a tank. It takes 7 minutes to fill the tank. What is the power of the pump? Okay, simple question. We know that power is energy or work done by time. So work done is 460 kilojoule, and then time is 7 minutes. This we have to be careful. We have to convert into seconds. So 7 minutes into 60 seconds. So if we do the math, we get I don't know, 1095 watt. Yes. So if you round off this, put it in a scientific notation, 1.1 kilowatt. So we have that in option A. Done. The water in a swimming pool exerts a pressure on the bottom of the pool. Which graph shows the relationship between the pressure exerted by the water and the depth of the water in the pool? Assume the density of water is constant. Okay. Now, what's the equation for pressure in a liquid, inside a liquid? So that is rho GH, P equal to rho GH. Now, none of this variable is squared or cubed, so it's a linear equation, which means the pressure versus depth graph should be a straight line. Okay, simple. As depth increases, pressure increases, directly proportional. So C is right answer. Why can a gas be compressed easily into a smaller volume? Why? The particles are far apart. That's the reason. In solid, already the particles are close enough, so it's difficult to compress further. In liquid, it's a different case scenario. Most of the liquids, most of the part you cannot compress. Okay, that's a difference. Even derivation from Pascal law, no need. The particles are far apart. That's the reason gas can compress easily into smaller volume. A gas is contained in a cylinder by a movable piston. The gas is heated so that it expands at constant pressure. How is the force of each collision of gas particle with the piston affected, and how does the frequency of collision between the gas particles and the piston change? Okay, we have to answer two questions. What happens to the force and what happens to the frequency of the collisions? Now, so gas is heated. If it expands at constant pressure, pressure is force by area. The area on the piston is not changing. Okay, so pressure is force by area, constant pressure increasing. So the force will increase. If the pressure increase, force will increase. Okay. How about the frequency? As the force increase, the piston will move towards right. Okay, so the volume is increasing. Volume increase means less frequent collisions. Okay, so the frequency of collisions decrease. Why it decrease? Initially one smaller volume, so they bounce back and forth very frequently. As you go on, the volume increases, so these collisions will come less and less obvious. Okay, at a point they no longer collide, so the volume will not expand. Okay, so force increases, frequency decreases. Frequency of collision decreases. Option A. On a warm day, a carton of fresh milk is covered with a wet cloth. Why does this help to reduce the temperature of the milk? We know that evaporation happens on the surface and it cools down the remaining liquid. So some water evaporates from the cloth so that the remaining water becomes cooler. Option A. A chef heats some water in a pan on a hot plate. The temperature of the water rises by 10 degrees Celsius in time t. She then puts the same volume of oil, in identical pan on the same hot plate. The specific heat capacity of water is 2.5 times that of oil, and water is 1.1 times denser than oil. What is the time for the temperature of the oil to rise by 10 degrees Celsius? Okay, this is a little bit tricky question, but not complicated, not at all complicated. Just you have to know the trick. What's the trick? Okay, let's start from what's the equation that we know. We know that E is mc delta theta. E is the change in energy, m is mass, C is specific heat capacity, and delta theta is change in temperature. Okay, now so we have to raise both temperature for 10 degrees Celsius. So what's the time required? This is the question. So what connects energy and time? We know that power connects energy and time, and power is energy by time. Okay, so since it's a identical pan and the same hot plate, we can assume that for both water and oil to rise some temperature, maybe same energy required, same power required. So power required or given to water is power required to rise the same temperature in oil. So we will take like that. So energy by time for water is equal to energy by time of oil. Okay. So I just put the equation with MW for mass of water, CW specific heat capacity of water, so everything what. Okay. So MC delta theta by T for water is equal to MC delta theta by T for oil. Okay. Now we do not have explicitly mass given in this question, but what do we have given is the volume. Okay. So they have put same volume. So and the density information is also there. Water is 1.1 times denser than oil. So how we can connect this both? We know that density is mass by volume. From that we can write mass is density into volume. So again we will put that in the equation. So density into volume of water, specific heat capacity of water, delta theta by water divided by time taken for water is equal to same for oil. Okay. And if we look, the volume of the water and volume of the oil is same, so we can cancel those things out. And the temperature delta theta for water 10 degree, they are asking the same increase in delta theta for oil, so that's also 10 degree, that also we can cancel out. So if we cancel out this volume and delta theta, then we have density and specific heat capacity by time is equal to density into specific heat capacity by time for oil. Okay. Now we have given that specific heat capacity of water is 2.5 times that of oil, and also density is 1.1 times of oil. Okay. So if you put this in the equation, instead of density of water and specific heat capacity of water, I just plug in 1.1 times density of oil and then 2.5 times specific heat capacity of oil. So now we can cancel out this density and specific heat capacity also, because we gave in terms of oil, right? So what we have left with 1.1 into 2.5 divided by time taken for water is equal to 1 divided by time taken for oil. So we just have to rearrange this equation. Time for oil is TW by 2.75. 1 divided by 2.75 is, I guess, 0.36 or something. Oh, it's yes. So 0.36 time taken for water. So that's our first option, A. Little tricky question. Assumption is very important. Okay. The diagram shows the view of a room heated by a radiator. The arrow line X from Y is the path of the convection current in the air. Okay. So the radiator heats the air. So the heated air or a hot air becomes less denser, so it will move up. So to fill that place, the cold air from somewhere else will come. Okay. So this is how it will work. If you heat, it will go like this. Yeah. So air temperature is higher at X because that's close to the radiator, and the air density is higher at Y because that's far from the radiator, so it's yet to be heated. So this will be still cold, so more dense. So air temperature is higher at X and then air density is higher at Y. Option B. Two men P and Q stand close to a gap in a wall as shown in the figure. Okay. Man P cannot see man Q, but man P can hear man Q speaking. Which statement explains? Okay. What are the statement discussing about? Light waves do not diffract all because they are no, light waves do diffract. Light waves have range of frequencies, but sound has just, that's also not true. Sound also have different frequencies. We can hear from 20 Hz to 20,000 Hz. That's also not right. Sound waves are of a higher frequency than lights. That's totally wrong. Light waves are higher frequency. Sound waves are lower frequency. Sorry. Sound waves diffract lot because their wavelength is a similar size to the width of the gap. Okay, what's the wavelength of sound wave? Let's try to calculate. So V is f lambda and lambda is V by f. Velocity of sound in a good day is 300 meter. divided by, let's say, 20 to 20,000 hertz. Let's take 20 hertz. So it's approximately 300 by 20, 150. Okay, so 15 meter. If it is 20,000, then it will be 15 millimeter. Okay, 10 power minus 3 less. So it's 15 millimeter to 15 meter wavelength gap. So this can diffract higher wavelength. This can diffract all the way. Okay, compared to light, you have wavelength in a nanometer, angstrom, 10 power minus 10, 10 power minus 9. This is very higher. So they differ a lot. So D is right answer. Sound waves diffract a lot because their wavelength is a similar size to the width of the gap. Yes, if you look that the width of the gap is almost equal to the person. So it's in meter. So wavelength of the sound is also same. Okay, and P and Q are not in line of sight, so they cannot see each other. If there is a mirror, they can. Okay, so D is right answer. Which quantities relating to a wave on the surface of water can both measured in meters? Amplitude and frequency. Amplitude can be measured in meter, but frequency has to be measured by hertz. Amplitude and wavelength is the right answer. Wave speed meter per second, frequency is hertz and wavelength. So B is the right answer, amplitude and wavelength. The diagram shows part of ray diagram that demonstrate the formation of a virtual image Y of object X by a converging lens. Okay, one ray of light from X is shown approaching the lens. Which arrow shows the direction of this ray as it leaves the lens? Sorry. Okay, it's a virtual image. Now it will look like this. If it is a straight line, it will go through the center of the lens. Now this image from X to the direction, it will again diffract. It should be a curve. Okay. So which arrow shows the direction of this ray as it leaves the lens? A, option A, which is parallel to the second. Okay. A ray of light is reflected by a plane mirror. Which row shows the angle of incidence and the angle of reflection? Okay, Q is angle of incidence, R is angle of reflection. What people make mistake generally is they take angle P sometimes for angle of reflection. No, angle of reflection and angle of incidence is from the normal to the plane. Okay, so the dotted line is normal to the plane, perpendicular. So Q and R is angle of incidence and angle of reflection. Thin converging lens is used to produce a real image of an object. Which statement about the real image is always correct? Okay, it's nearer to the lens than the object. No, that's not true. Need not be. It's on the opposite side of the lens to the object. This is true. It's the same size as the object. Also, again, not true. It can be varied by the position. It's upright. Need not to be true. I mean, not upright. It's always down. Okay, up down. So B is right answer. A radio transmitter broadcasts frequency at 200 kilohertz. What is the wavelength of these radio waves? Okay, we can find V equal to F lambda. Lambda is V by F. This is electromagnetic wave, so speed is 3 into 10 power 8 by frequency is 200 kilohertz. Kilo is 10 power 3. So 1500 meter. I think this is option C, 1.5 into 10 power 3 meter. Okay. The element mercury exists as a solid, liquid or gas. Which row gives possible set of values of the speeds of sound through mercury? Okay. So in general we know that sound travels faster in solid, less faster in liquid and then slower in air. So sound should be faster in air, little more faster in liquid, little more faster in the solid. I think D. Yeah, so 250, 1500 and 2500 increasing from gas to solid. Okay, which metal could be used for a permanent magnet and which metal could be used for a core of an electromagnet? So we know from the book it's steel and iron. Okay, steel is permanent magnet candidate and then electromagnet, iron is electromagnet candidate. Which statement describes the direction of an electric field at a point? Okay, what is electric field? So the lines, if you put something in which direction a positive charge will move, that's electric force. If you take the negative charge and then the lines are going in, so meaning that if you leave a positive charge, it will go towards the negative. If you kept a positive, the lines are going out, so if you put a positive, it will go out. So the direction of force on a positive charge, C. Which statement about a voltmeter is correct? It has a scale which is marked in amperes. No, current is marked in amperes, ammeter is marked in amperes. It must be connected in series. No, it should be voltmeters should be connected parallel in a circuit. It measures potential difference. Yes, this is the right answer. It must have 3 terminals. No, voltage you can measure only between 2 terminals. A wire has resistance of 8 ohm. Second wire of the same material has twice the length and twice the cross sectional area. What is the resistance of the second wire? Okay, nice. We know that resistance is rho into L by A, rho is resistivity. Let's take the new resistant, which is same material, so resistivity is not going to change. It's an intrinsic property of the material. Length is twice, so 2 length, and cross sectional area is twice, so 2A. You have to be little careful. If they mention that the diameter is twice, then you have to work out what's the radius and then you have to square it, because area of cross sectional is pi r square. So here they have gave cross sectional areas twice, so we just put 2A. Now this 2 and 2 cancel there, so you are getting just rho L by A, which is same as the initial resistance, so 8 ohm. A plastic rod is rubbed with the cloth and the rod becomes positively charged because of the movement of the charged particles. Which row gives the name of these charged particles and the direction in which they move? Of course, electrons, and then rod becomes positively, meaning that electrons have moved from rod to cloth, so B. Okay, an alternating supply is connected to a diode and a resistor in series. Which graph shows the how potential difference V across the resistor series with time? Okay, diode, one single diode is connected, so this is like a half wave rectifier. So in AC supply, it's going to allow current only in one direction. Okay, sorry, voltage in one direction, so only the top will get, the bottoms will cut out, so option C. Okay, so this is a graph of a half wave rectifier. The diagram shows a circuit used to switch on heater when the temperature drops below certain value. Which row shows the components that should be connected at X and Y? Okay, so now heater is connected across Y, so when the temperature decreases, the voltage across Y should increase. So this is simply a potential divider circuit. So thermistor, we have to use a thermistor. Thermistor's resistance will increase if the temperature decrease, because in our syllabus we have only NTC, negative thermal coefficient temperature. Okay, thermistor. So we should put thermistor at Y and we should put a constant resistance at X. So in this manner, if the temperature decreases, the Y resistance will increase, so the voltage across it will increase, so that the heater will turn on. Okay, B is right answer. A current in a solenoid produces a uniform magnetic field inside the solenoid. the magnetic field direction is due east. Which change will produce a stronger magnetic field with direction due west? Okay, initial magnetic field is east. Now which change will produce stronger magnetic field with direction due west? So we have the magnetic field, okay, is directly proportional to current. So we have to use a larger current, and current in the opposite direction, meaning the reverse current. Okay, even if you just turn that solenoid, it will not make any difference because it's just copper, and then the direction will not change, current. Okay, so we have to use a larger current and reverse the current. So D is the right answer. A metal rod PQ rests on two horizontal metal wires that are attached to a battery. The rod lies between the poles of a magnet. When switch is closed, the rod moves to right. Okay, what could be changed so that the rod moves to the left? So what has to be changed? The direction of the current has to be changed. Nothing else should be touched. Okay, or if they give the option, we can change the magnet also, but there is no option, nothing discussed about changing the magnet. So reverse the battery terminals but without changing the poles of the magnet. Okay, you can change only one, not both. So C is the right answer. If you change both, again it will move in the same direction. Yes. Okay, a transformer in a computer is used to transform the main voltage 240 volt to 12 volt. The number of turns in the secondary coil is 2000. Which statement about the transformer is correct? Okay, whether they are asking step down or step, definitely it's a step down transformer because from 240 to 12 volt it's transforming. Now what's the number of turns? We have an equation for that. Ns by Np is Vs by Vp. So S is secondary, P is primary, N is number of turns, V is voltage. So we have to find the number of turns in the primary coil. So let's rearrange this equation for Np. So Ns dot Vp by Ns, and put the numbers. We are getting Nps 40,000. Okay, so it's 40,000 turns in primary coil and it's a step down transformer. So option B. Okay, in alpha particle scattering, alpha particles are incident on a thin metal foil. Which road describes results from the experiment and conclusion that the results lead to? Okay, so alpha particle incident, what they are discussing, most of the alpha particles pass straight through the foil. Okay, so very few of the alpha particles pass straight through the foil is not true. Most of the alpha particles pass through the coil. Okay, so option C and D is gone, only A and B, and this gives the result most of the atom is empty space. So option A is right answer. Alpha particles, beta particles, gamma rays are emitted by radioactive nuclei when they decay. Which emissions can be detected by an electric field? Alpha and beta particles are charged. Alpha is positive and then beta is negative. So only alpha and beta can be detected by an electric field. So alpha and beta particles only. So gamma doesn't have charge, neutral. Okay, so radio isotope X decays to the stable isotope Y. The graph shows how the mass of Y present in a sample varies with time. Which time interval gives the half-life of X? Okay, so when we are looking at this graph, we are very tempted to answer T3 minus T2. It looks like right, okay, but it's not. So the T3 minus T2 will give somewhere around T3. Okay, if you look at the magnitude of T2, if you subtract it, you will get close value to T3. That is not at all reflecting quantitatively or qualitatively what is half-life. What is half-life? How long it takes to come from 100 to 50, half of the original value. So initially it's M, how long it takes to come to M2, that's in T2 time, or from M2 to M4, that is T1 time. If T1 is their answer, we can check T1, but it's not. So T2 is there, so T2 is the answer. What is a half-life? Just amount of half time take to for the nucleus to come from original, let's say 100 to half 50. Okay, so C is the answer, T2. Which particle is observed by a nucleus to cause nuclear fission? Neutron is observed. This is a general, more way fast neutrons, okay, high energy neutrons. It is somewhere in the northern hemisphere of the earth in June. Which statement explains why? Okay, so somewhere in the northern hemisphere of the earth in June, so meaning that north pole of the axis of the earth's rotation is tilted towards the sun in the June, so that the rays are more close to perpendicular when they are hitting the earth. So D is the right answer. Earth is closer to the sun in June does not explain why there is winter in southern hemisphere in June. Okay, okay, so other two options are relevant. Which statement about the sun is correct? Sun is a medium sized star consisting mostly of hydrogen and helium. So option C. The table lists some information about some stars. Which star will eventually explode as supernova? Okay, so the temperatures are given, but it's relevant but not to IGCSE syllabus. So we know the order of how birth and death of the star. Okay, so after red supergiant only it will explode as supernova. So option B, whatever goes that star is, it will turn into or explode as a supernova. Okay, that's a 40th question. Thank you, Hariharan Ponmani. If you want any other video, particular paper, please let me know in comment. Yeah, see you, bye bye.